All right, this video is over solving quadratics by square roots. Quadratic equations of the form ax squared plus c equals 0, so no bx term, can be solved using square roots. So the first thing that you want to do is you want to isolate the x squared, meaning that you want to get this x squared over on the left-hand side by itself. So how do we move the 49 over? We're going to add it over. So that turns into x squared equals 49. Then we're going to take the square root of both sides to cancel out the 2. Actually before that though, if there is something in front of the x squared, you'd have to divide by that first, and then you would take the square root. Okay, we don't have anything, so we're just going to take the square root of both sides. Okay, the square root of 49 is 7, yes, but technically you have -7 as well, because -7 times -7 is a positive 49, and a positive 7 times positive 7 is also positive 49. So the way that you write your answer is you just say plus or minus 7. Okay, and if you wanted to write this in a solution set, you would say x equals squiggle brackets -7 positive 7. Okay, but I will take this answer right here as well. Okay, you can write it either way, but this still gives you the same answers as what we've been finding, where our parabola crosses the x-axis. That's what we're looking for. Okay, so the same thing. So it says, remember that a positive number always has 2 square roots, which is a negative and a positive. Okay, so on number 1, to isolate the x squared, we want to add 16 over. So x squared equals 16. Take the square root of both sides. The square root of 16 is 4, so you say plus or minus 4. Number 2, add 100 over. X squared equals 100. Take the square root. Square root of 100 is 10, so x equals plus or minus 10. Number 3, subtract 25 over. X squared equals -25. Okay, take the square root of both sides. If you try to take the square root of a negative, you're going to get an error message. Okay, now when we get into algebra 2 later on in a couple years, you're going to learn about imaginary numbers, and that's when there's a negative underneath a radical. Right now, we're not going to do that. And what we're talking about is we're talking about solving quadratics. So if we were to solve quadratics, then that means that this would be where your parabola does not cross the x-axis. So this would be a no solution, is what your answer would be. Number 4, subtract 7 over. X squared equals 81. Take the square root of both sides, plus or minus 9. Number 5, add 5 over. X squared equals 1. Take the square root. X equals plus or minus 1. Number 6, to get x squared by itself, we have to divide both sides by 6. So x squared equals 9. Take the square root, plus or minus 3. Number 7, divide by -2. X squared equals a -98 divided by -2 is 49. Take the square root of both sides. X equals plus or minus 7. Okay, number 8. You can't divide by a fraction, so instead you have to multiply by the reciprocal. So we multiply both sides by 4/3. So x squared equals, 48 times 4, 48 times 4/3, just go ahead and do the entire thing, is 64. Take the square root of both sides, and we have x equals plus or minus 8 as your answer. Number 9, first you want to add 108 over. So we have 3x squared equals 108. Then we want to divide by 3. 108 divided by 3 is 36. So if x squared equals 36, so then take the square root of both sides, and x equals plus or minus 6. Number 10, we want to add 45 over. 5x squared equals 45. Divide by 5. X squared equals 9. Take the square root of both sides. X equals plus or minus 3. Okay, let's flip over to the other side. All right, let's skip down to 15. Okay, well, first we want to get all the x squareds on the left-hand side. So we've actually got to subtract the x squared over here to start off with. Okay, and that turns into a 4x squared, but the 1 we want to move over to the other side, so we've got to add 1 over here. So we have 4x squared equals 1. Okay, then we want to divide by 4. So x squared equals 1/4. Take the square root. When you're taking the square root of a fraction like that, you can actually take the square root of the numerator and the denominator each. So that turns into plus or minus, the square root of 1 is 1, and the square root of 4 is 2. So plus or minus 1/2. Okay, 16, you can add 34 over. So we have 16x squared equals, what is that, 49? Divide by 16. So x squared equals 49 over 16. Take the square root. Square root of 49 is 7, and the square root of 16 is 4. So it's plus or minus 7/4. Okay, so now irrational solutions. So it says zeros can be irrational. Solve the following quadratic equations. Write all answers in simplest radical form. Okay, we've already talked about simplifying down radicals. We talked about that before school got out. This is the same thing. Okay, you're still solving exactly the same way as what we're doing. So you want to add 3 over. So x squared equals 3. Take the square root. This is the part that we have already learned. Can we simplify down the square root of 3? No. So you just say x equals plus or minus the square root of 3, and that's your answer. On 18, you want to add 8 over. X squared equals 8. Take the square root. Okay, on this one, what's the largest perfect square that goes into 8 evenly is 4. So that breaks down into 4 and 2, because 4 times 2 is 8. The square root of 4 is 2. So you say x equals plus or minus 2, square root of 2 is your answer. 19, and subtract 8 over. X squared equals, well, 56 minus 8 is 48. Take the square root. Okay, the largest perfect square that goes into 48 evenly is 16, and that's 16 times 3 is 48. The square root of 16 is 4, so you say x equals plus or minus 4, square root of 3. 20, you want to add 16 over. So x squared equals, well, 59 plus 16 is 75. Take the square root of both sides. What's the largest perfect square that goes into 75 evenly is 25. That's 25 times 3. So x equals, the square root of 25 is 5, so x equals plus or minus 5, square root of 3. Okay, 21, you want to add 126 over. So you have 2x squared equals 126. You want to divide by 2. X squared equals 126 divided by 2 is 63. Take the square root of both sides. The largest perfect square that goes into 63 evenly is 9. So that's 9 and 7. Okay, so we have x equals plus or minus, the square root of 9 is 3, and we have the square root of 7. Okay, on 22, you want to subtract 8 over. So you have negative 3x squared equals a negative 30. Divide by negative 3. X squared equals 10. Take the square root. You cannot simplify the square root of 10, so you just say x equals plus or minus the square root of 10. 23, you want to add 10 over. Negative x squared equals 28. Divide by negative 1. We have x squared equals a negative 28. Take the square root. Cannot take the square root of a negative, so it's a no solution. Last one here, we want to add 11 over. We have 1/2 x squared equals 36. Okay, you can't divide by a fraction, so instead you multiply by the reciprocal. The reciprocal of 1/2 is 2, so we're multiplying by 2. So x squared equals, well, 36 times 2 is 72. Take the square root of both sides. What's the largest perfect square that goes into 72 evenly? That's 36 and 2. The square root of 36 is 6, so x equals plus or minus 6 square root of 2. And that is your answer. Okay, so you only have to do this if you cannot simplify down by taking the square root, if you cannot take the square root of it, okay? Otherwise, you're just doing like what we did on the first part up here. And remember that these are still giving you the solutions, the x-intercepts, so on and so forth. It's just giving you where your graph is going to cross the x-axis. And if it's a negative, like number 3, that means it does not, the parabola does not cross the x-axis. It's a no solution.